Okay, so this is a review on how to use the sine law. One will first find the side length, and then we'll use the sine law to find an angle. So when using sine law, you always want to be able to have what we call one full ratio, where you have an angle and a side across from each other, and you know both numbers. And then you want to be able to have another ratio where you know one of the values, and you're trying to find out the one across from it. And so when you set up the sine law, I'm going to put c over sine c first because I'm trying to find side c. And then I'm going to put b over sine b second because that is the what we call my full ratio where I know both values. So c over sine c equals b over sine b. And then I'm going to put my numbers in. So I don't know side c, but I know the angle over equals 3 over sine 65. And then when I'm calculating this, I want to do the opposite of what's happening to c. So this fraction line means c divided by sine 40. So I'm going to do the opposite of that on the other side of the equation. I'm going to go 3 times sine 40, and then I'm just going to leave my sine 65 on the bottom. But when I type this into my calculator, I will type it in as 3 times sine 40, and then because of that fraction line, I will go divided by sine 65 to get an answer of 2.13. And you'll want to make sure your calculator is in degree mode, so if you got a different answer, then maybe your calculator might be in radians or in gradients. So you want to make sure your calculator is in degree mode. Look for a way to change that if it's not. So that's how you find a side. Pretty straightforward once you fill the formula in. Now when you're finding an angle, same thing. To get started, you want one ratio where you know both numbers. In this case, it's going to be r. And you want another ratio where you know one value and you're looking for the other one. And this one's going to be p. We use little letters for side lengths and put them across from the capital letters for the angles. So this time when I set up my formula, I'm looking for angle p. So I'm going to put sine p on top of the fraction, little p on bottom. And then when I put my full ratio, I'm going to put sine r on top and little r on the bottom. And that's because we're looking for an angle, and we want the angles to be on top of our equation. So we fill in what we know. We know, so that's supposed to be a p right there. And we know little p, side p is 7. We know angle r is 110. And side r is 15. And we're going to do the same step as the other example. Over here it is sine r divided by 7, so we are going to do the opposite of that. On the other side of the equation, it's going to be sine 110 times 7 divided by or over 15. Make sure, depending on how your calculator works, make sure that it's sine of 110 and then times 7 and then divided by 115. So we're going to do that, and you're going to get an answer that will not look like the final answer, and that's okay because there's actually going to be one more step that we need to do. So sine 110 times 7 divided by 15 gets us an answer of 0.4385. We're going to do 4 decimal places on this. So equals 0.4385, and even better, keep the number on your calculator with all of the decimal places. And we have to undo this sign here, and so the way we're going to undo that is we're going to take what we call the sine inverse. It looks like sine -1 of 0.4385, or if you can do more decimals because you have it saved on your calculator, that's great. And that will turn that decimal into an answer that looks much more like a value we'd expect when we're looking for an angle. Sine inverse of 0.4385 gives us an answer of 23.00, so we can just say 23 degrees. So R is equal to 23, or 23, I'm not sure where the 23 is coming for, it should be 26 degrees. And that's a quick little review on how you find a side using the sine law, and how you find an angle using the sine law. So this slide is about using the cosine law, and so you'll notice we always want to try to use the sine law first if we can, but you'll notice we do not have a full ratio. We do not have both values at angle and a side across from each other, so that's how we know we can't use sine law and why we're going to use the cosine law. So the cosine law has many different forms, and usually it's written with A, B, C, and or A, B, and C. So A squared equals B squared plus C squared, take away 2BC times cos of angle A. But this little triangle we have has D, E, and F on it, and we're looking for angle E. So I'm going to rewrite this formula with E. I'm going to put E where the A is, and then I'm going to put D and F where the B and the C are. D and F can get switched, it doesn't matter, but if we want to find angle E, we have to put the E's where I put them. So that is how we can rewrite the formula, and then we're going to input all of the knowledge that we know. So side E is across from angle E, side F is across from angle F, and side D is across from angle D. So if we put those numbers in, we get 5 squared equals 8 squared plus 8 squared, because D and F are the same, take away 2 times 8 times 8 times the cos of angle E, which we're trying to figure out. So that is our unknown, and we've got there's two ways we're going to solve this. First is we're going to do any bedness, any calculations that we can do. So 5 squared is 25, 8 squared is 64, and then if we add that again, because we have two 8 squareds, we've got 64 plus 64, which is 128, minus 2 times 8 times 8, we can do that together. And that's going to be one of those odd things where we're going to get the same answer, 128 again. It's just a coincidence that we're getting that. Cos E. Now, be really careful. That's the only calculations we cannot do, or that we can do. We do not subtract these two numbers here because the second 128 is attached to the cos. So because of Bedmas rules, that's as far as we can go with Bedmas. We can now start undoing operations. So if our goal is to figure out what the E is, we've got to undo the cos, we've got to undo the 128 times, and we've got to undo this 128 here. So working backwards, we're going to start off by subtracting 128 from both sides. That gets us 0. And 25 take away 128 should be what? Negative 103? So that gets rid of the one step. That negative here sticks with that 128. And now we're going to undo the multiplication. So the opposite of multiplying is dividing. So we're going to divide by 128. And sorry, I should say divide by negative 128. And so that is going to get us one of those weird decimals. It should be a positive number because we're dividing two negatives. So 123 divided by 128 is 0.8046. We're going to do 4 decimal places. 0.8046 equals cos of e. And just like the previous examples of sine law, that does not make up a lot of sense as a final answer, but that's okay, because we have to undo the cos of e by doing the cos inverse. So cos inverse, or cos negative 1 of 0.8046, and that will get us our answer, the angle that we're looking for. Again, make sure your calculator is in degree mode. So 36.4 degrees. So I'd recommend, sometimes angles get rounded to whole values, sometimes we do at least 1 decimal place. And especially in this case, 36.4 is almost half of a degree. So there we go. That's how you find an angle using cosine law. And the next example we're going to do is how to find a side. So we've got cosine law. We've got to draw a triangle, given triangle ABC, with side B being 10, so that's across from the angle. Side C being 12, that's across from angle C. And then we've got angle A being 25. So we cannot use sine law, again, because we don't have that matching side and angle across from each other. So that's a big clue that we're going to use cosine law. And we're going to use the same formula that we started with last time. The a squared equals b squared plus c squared. Take away 2bc cos A. And this, we don't have to make any changes to this because we have angle A, we have side B, we have side C, and we're looking for side A. So this one's already set up perfectly. So put the numbers we know into the formula. 10 squared plus 12 squared, take away 2 times 10 times 12 times the cos of 25 degrees. And depending on your calculator, you can type all of this in one step if you want, or you can break it up, whatever you prefer. So 10 squared is 100, 12 squared is 144, so that should give us 244. And we add those together. And then I like to do this whole next step together, but it means we're going to get a decimal, so you're going to have to make sure you hang on to some decimal places. So 2 times 10 times 12 times cos of 25. That gets us 217.514. 217.514. Then we can subtract those. And there's just one little final step you have to make sure you don't forget to do at the end. Because right now we're actually just solving for a squared. So we're going to have to get rid of that little squared symbol on the left side of the equation. So after we subtract, we get 26.486. That should seem a little large, and that's okay, because like I said, we got to do the opposite of a squared, which is square root. So square root of 26.486 should be 5 decimal something, and then that'll be your final answer. So that is definitely the more straightforward calculation, finding the side length using cosine law. As you can see in the first example, finding an angle takes a few more steps. So what did I say? 5.14. So we'll say 5.1. Side lengths are usually rounded to either 1 or 2 decimal places. There you go. That is how you find angles and sides using cosine law. Okay, so this is going to be just some more review on cosine law and sine law. So I'm going to try to do this fairly quickly since I already did examples on the other questions. I just want you to be able to check your work. So we've got three sides here. We've got P at 7, we've got Q at 6, and we've got R at 9. And so we talked about our formula before being a squared equals b squared, etc. But because we're trying to find angle P, and we've got P, Q, and R, I know it needs to be cos P because that's the angle I'm looking for. And that means my formula has to be P squared equals. And then I just put Q and R in for the other letters. So Q squared plus R squared, take away Q2 times Q times R times cos P. And then you're going to fill in your values. And then you're going to do as much bedmas as you're allowed to do. So any calculation that you can do before we start working backwards will make things easier for us. So you can square the 7, you can square the 6 and square the 9 and then add them together. So 6 squared plus 9 squared is 117. And then we can multiply 6 and 9 and 2 together, and that should get us 108. And this is where you have to be careful. This 108 is attached by multiplication to the cos, so we cannot subtract it from 117. This is where we have to start working backwards. So we're going to go 49, take away 117, and I'm going to write this in one step just to speed things up, divided by negative 108. So that undoes those two values and leaves us with cos of P. Now when you go 49, take away 117, make sure you either use brackets or hit equals before you divide. We want to make sure the bedmas rules are followed. So 49 take away 117 is negative 68. And then we are going to divide that by the negative 108. And that's going to get us 0.6296. 6296 positive because we were dividing two negatives. And then we undo the cos by applying cos inverse to the 0.6296. And that will get us an angle of cos inverse of 0.6296 is 50.97, or we can run that up to 51 degrees. So that's a quick rehash of cosine law. And then let's do a quick review of sine law. Or if you have this done, you can just kind of speed ahead and check your answer. So we've got triangle DEF. We've got side E being 6.9, side F being 4, and angle E being 120. So we can see right away how we have our full ratio here, the 120 and the 6.9, and we're trying to find angle F, and so that is going to be our other fraction. So I'm going to start with the unknown. I'm going to start with sine F over F, because we don't know that angle, and that equals sine of angle E over E, because we know both of those values. Do a quick substitution. Side F is 4, angle E is 120, and side E is 6.9. And then to solve, we have to do the opposites. So we're going to multiply the 4 to the other side. Just watch your brackets when you're typing this into the calculator. And then we're going to divide it by 6.9. And you're going to get a weird decimal, and that's okay. So 4 times sine of 120, and then divided by 6.9. Gets us 0.5020. And then we undo the sine by doing sine inverse of that value. So sine inverse of 0.5020 gets us an answer of 30.1 or 30 degrees. So there's a quick review on how to do angles using sine law and angles using cosine law. So sine inverse of 0.5020 equals 30.1 degrees. Okay, we're going to end off with a word problem here. See if we can apply our sine law and cosine law formulas. So we have a tower. It is 200 meters tall and leaning to one side. So probably just leaning a little bit. And so that's my tower, leaning 200 meters. And from a certain point on the ground, the angle of elevation to the top is 70 degrees. And then from a point 55 meters closer, so this is 55 meters, even though this is going to connect to make a triangle. From that point, the angle of elevation is 85 degrees. And we're trying to figure out the angle from which the tower is leaning. So we're trying to figure out how far it's pushed over. So to figure out this question, we are going to start and focus on just this triangle here. So I'm going to draw that out over here. We've got 70 degrees here. We've got 55 on the bottom. And that seems to be all we know. But we can figure out this angle here by going 180 minus 85. So that's going to be 95. And if we know that angle, then we can figure out this angle up here by also subtracting from 180. So 180 minus 70 minus 95 is 15 degrees. Now, it's like a puzzle. You're trying to figure out as many pieces of information as you can. Our goal is to figure out this side here so we can use it on the other triangle. So I want to figure out this side, and I have that matched up with the 70, and I also have the 15 matched up with the 55, so I can do sine law. I know question mark over sine 70 equals 55 over sine 15. So we're going to solve for the missing side length there by doing the opposite of dividing by sine 70 and going 55 times sine 70 and then dividing that by sine of 15. And that's going to get us that missing side length of 199.68. So I did 55 times sine 70 divided by sine 15, and that gets us an answer of 199.7, we'll say. So I can fill that in here, 199.7. And so now I'm going to draw what I have for this part of the triangle. So I just figured out the 199.7. I know the tower itself is 200. I've got 85 degrees down here. And I'm going to try to figure out this angle here, so I can figure out what angle that tower is leaning at. So I'm going to do sine law again. I've got the 199.7 across from the question mark, and I've got the 200 across from the 85. So I'm looking for an angle So sine's going to go on top. And then I do a matching ratio here. I've got sine 85 over 200. So first step is to multiply the 199.7 up, divide by the 200, and that's where you're going to get that strange little decimal place, but there's an extra step to do at the end to turn it into a more reasonable answer. So sine of 85 times 199.7 divided by 200. We're going to do 4 decimal places. So 0.9947. And then you're going to do sine inverse of 0.9947 to get an answer of 84 degrees. So sine inverse 0.9947 equals 84.1 degrees. And so that is the angle that is in this bottom corner here. (84.1 degrees). So depending on how you look at this, it says how much it's leaning from the horizontal. So it's leaning basically 84 degrees from the horizontal. If we want, that means it's 84 degrees up here as well, because of this like little Z pattern we have. You also maybe could figure out how much it's leaning on the other side of this line, but that would be from the vertical, and so that's not what the question asks. It just wants to know how much it's leaning from the horizontal. So 84 degrees or 84.1 degrees from the horizontal, that is your final answer.